Good morning. How are you? Hope you are all in the pink of health. I am Atunurai and you are watching Bond Making and Bond Breaking channel. Okay. So after complete my third video, I am going to create fourth video on preparation of phenol. On my first video, I give you introduction and UPAC nomenclature. On the second video, I give you physical properties. On the third video, I give you chemical properties and chemical reactions of alcohols. Now, I am coming to give you the preparation of phenol. So, right, preparation of phenol. What do I say? Preparation of phenol. Okay, preparation of phenol. First point, preparation of phenol. First point, you take just benzene. Just take a benzene. This is the benzene, and it reacts with chlorine with Fe or FeCl2, and it gives you if you react with FeCl2 with Cl and Cl, you get FeCl3 and Cl also. So the product is Cl. Okay. So the product is Cl. And when you want to react with fume, let's fume NaOH, with fume NaOH, you get fume NaOH, you can get okay, you want to react with, so you get ONA. Due to H and Cl, HCl is removed from here. Okay, so ONA is here, and you give for acidification or H plus. What do you get? You get that phenol OH. Na is plus and O is minus, so minus plus is going here, so you get OH as a phenol. So this is the preparation benzene to phenol. This is the preparation of benzene to phenol. Benzene, you take chlorine and you get chlorobenzene with the help of FeCl2. When you get chlorobenzene, you use fume NaOH and it gives you sodium phenoxide. So sodium, when you acidified it, by the acidification you get phenol. Okay, this is the first. And the second one, first preparation, and the second one by cumene. By the second one is by cumene. Then you take CH3. This is cumene, or you can call it isopropyl benzene. You can also call it isopropyl benzene, but I say isopropyl benzene. Okay, then this isopropyl benzene, when you react with oxygen and H nu, you get CH3OOH. This is the product after react with oxygen and H nu. Then you acidified it. Through this acidification, you get as a side product ketone CH3COCH3. So that is ketone, acetone. You get as a side product acetone, and with this reaction you get phenol. Okay. So this is the preparation by cumin. So this is the preparation of cumin. So the first reaction I say, or I give you benzene to phenol preparation. This is my first preparation, and second is isopropyl benzene, that is cumin to phenol preparation. Okay, these two preparation of phenol. Look, and the third one by Grignard. Okay, by the third one is Grignard. You take chlorobenzene. And you react with Mg and dry. You react with benzene and dry ether. You get Mg. You get MgCl. When chlorobenzene is reacted with Mg with diether, you get MgCl. And MgCl, when it reacts with H2O2, when you react with O2, you get half O2. You get OMgCl. Okay, Cl. When you want to react with Mg, you get MgCl, and it reacts with oxygen, you get OMgCl. Okay, so OMgCl, when you acidified it, H plus and OH minus, therefore it is minus and it is plus, so it reacts with it and you get phenol. MgCl and OH. This is the preparation. So I give you the first preparation, that is benzene to phenol. This is the first. Second, cumin to phenol. This is second one. And it is the third one. I give you chlorobenzene to phenol. This is the third one. Okay, so this is the third one. Then bisulfonic acid. Okay, then bisulfonic acid. You take benzene. Number 4 preparation. You take benzene. This is benzene, and it reacts with concentrated H2SO4. Or you can write it concentrated H2SO4 with SO3. So H2S2O7. What I get? H2S2O7. You can write it. When you use it, you get SO3H. Okay. Benzene react with concentrated H2SO4 and SO3, you get H2S2O7, then you get benzene sulfonic acid. Okay, then it react with NaOH. What you get? When you react with NaOH, what you get? You get NaSO3. OH and H is removed from here, therefore it forms water, and NaSO3 you get. Then you react again this So you get ONA. What you get? You get ONA, sodium phenoxide. Then you acidified it. And you get phenol. Very easy step. Then you get phenol. Okay. So this is the method 4 to prepare phenol. Okay. Now I have another process, that is by benzene diazonium chloride. Just you have this aniline, NH2 and benzene, aniline, and you want to react with NaOH and HCl. NaOH and HCl, and the temperature is 0 to 5 degrees centigrade. You get the product benzene diazonium chloride, N2 plus Cl minus. So when it reacts with water, you get phenol. So this is also a method to prepare phenol. This is the 5th process. Okay. Okay, very good. And the 5th one is, I give you a question, then I am going to chemical reaction. I give you a question, okay? Solve it. The question is, write the appropriate order, write the appropriate acidic order. Okay, then you get C2H5OH, you can get phenol, then I give you phenol with the position nitro, that is nitrophenol, orthonitrophenol, then paranitrophenol and metanitrophenol. Then I give you paranitrophenol, and I also give you metanitrophenol. So those are the problems. I give you short tricks. I give you the value 1, 2, 3, 4, 5. I give you the value of pKa. Okay, 1, 2, 3, 5 compounds. One is ethanol. So I give you the pK value 15. This is 10. It's helped you to understand. This is 7.2, this is 7.1, and this is 8.3. Those are the pK value. Always remember it. pKa means minus log of Ka. pK means minus log of Ka. So if the value of Ka increase, then the acidic nature decrease. What I say? With increasing the value of Ka, acidic nature decrease. What I say? With increasing the value of Ka, acidic nature decrease. Okay, very easy. So from here you can see that the value of pKa means Ka, the value of Ka inversely proportional with the acidic nature. So you can give this answer easily. You just note down it. Okay. Okay. Now I am going very important part of this part, that is chemical reaction of phenol. Number one, chemical reaction of phenol. Number one, very important, that is Riemann-Tiemann reaction. What is it? Riemann-Tiemann reaction. Now right, you just take phenol, okay. You just take phenol and react with NaOH and CHCl2 with some water. But I give you NaOH, CHCl2 and water. Phenol is react with sodium hydroxide. Very carefully you should remember it. Phenol react with NaOH and CHCl2 with water. What you get? You get that salicylaldehyde. This is OH and you get CHO on ortho position of the phenol. So this is very important. Okay, salicylaldehyde. Now the second one is Kolbe reaction. What is it? Kolbe reaction. Number two, you get, as usual, it is phenol and you want to react with NaOH. If you want to react with NaOH, you get ONA. OH, it gives you ONA, and when you acidify it with carbon dioxide, okay, and the acidification, it gives you a product. For this acidification you get OH and COOH. This is salicylic acid. So you can prepare by these two methods. One is phenol to salicylaldehyde, or phenol to salicylic acid. Salicylic acid. These two very important. When you want to prepare salicylaldehyde by phenol, you use Riemann-Tiemann reaction, and when you want to prepare phenol to salicylic acid, you used Kolbe reaction. Okay. Now I am going to the third reaction, that is nitration. So the third one is nitration. Okay. For nitration, you should use concentrated H2SO4 and concentrated HNO3, or only concentrated HNO3. That also give you the nitration product. If you use concentrated HNO3 and H2SO4, you get OH, NO2, NO2 and NO2. Orthopara, and this is called picric acid. They say picric acid. This is called picric acid. When phenol is react with concentrated HNO3 and H2SO4, you get this picric acid. Okay, very shortly get this picric acid. Or if you react it dilute, not concentrated, dilute HNO3 and H2SO4, you get two products. you get two product, NO2 on the meta position and NO2 on the para position. But due to this hydrogen bonding between O and H, due to this hydrogen bonding, this is the major product and this is the minor product. This is major product and this is minor product. Okay. Next reaction is halogenation. Okay. Next reaction is halogenation. For a halogenation reaction, you take this phenol and you want to react with bromine with the presence of CH2 and HCl. CH2 and HCl. Okay, you get two product. As you know that is bromine on ortho position and one bromine is on the para position. So this is the product when you react with bromine with the presence of CH2, carbon disulfide. But if you want it to react CaCl3, HCl, CaCl3, okay. If you want to react bromine with aqueous, with water, you get this product. Bro. Oh, 1, 2, 3, 4, 5, 6. So these are the 2, 4, 6 tribromo 2, 4, 6 tribromo phenol. Okay, this is orthobromophenol and this is parabromophenol. Okay, now the sulfonation reaction. Now the reaction is sulfonation reaction. Those are very simple, very equal. For sulfonation reaction, if you use concentrated H2SO4, we know that concentrated H2SO4 it gives SO3H as a nucleophile. Concentrated HNO3 it gives you NO2 as a nucleophile. HNO2 or HNO3. HNO3 and H2SO4 gives you NO2 product for the nitration. Okay. Anhydrous AlCl3 and Cl2 gives you Cl as nucleophile product. Anhydrous AlCl3 and CH3Cl, it gives you CH3 as a nucleophile product. Anhydrous AlCl3, it reacts with acyl chloride, it gives you COCH3 as a nucleophile product. So this nucleophile product is used for this reaction. You just remember these. For sulfonation SO3H. So it takes the appropriate position. For this appropriate position is ortho position SO3H, this is appropriate. So that if you use H2SO4 SO3H you get, so SO3H you just use it on an appropriate position. So SO3H on the ortho position because this position is very authentic, or you use this OH on the meta position. So this is SO3H. Okay, this is sulfonation reaction. You note this. Now the reaction is reduction. You take this phenol. For reduction you use Jaden dust. Okay. For Jaden dust you get benzene. This is the reduction. This reaction is called the reduction. Reduction is occurred. So this is the reduction. Now the reaction is oxidation. If you want to oxidize this, you use Jones reagent. Jones reagent. Okay. And you get, this is very important, benzoquinone, parabenzoquinone or benzoquinone. Benzoquinone. This is oxidation. Those are the simple reactions. Okay. For firstly, we give on this, or we see on this chemical reaction. One is Kolbe reaction, another is Raman-Chapman reaction, another is nitration, then sulfonation, then halogenation, then reduction, then oxidation. Those are the simple chemical reaction for this phenol. Okay, for this phenol. So thank you. Have a nice day. Take care of your health.